So once we have sequences, we want to find their sum, which of course is the series. And we have a formula for the series that says the sum is the first term multiplied by this ratio, 1 minus r to the n divided by 1 minus r. And r can't be 0 because then we wouldn't get a sequence. It would be all zeros, and it can't be 1. So we need to find the sum. Again, this is our sigma notation. What this means, we'd have 4 times 3 to the 1 minus 1 power plus, because of sigma, 4 times 3 to the 2 minus 1 power plus 4 times 3 to the 3 minus 1 power. Keep going to the 6th one. So you could manually write that out, calculate it, and find the sum. But let's use this formula instead. How am I going to get the first term? Well, the first term is by plugging in 1 for k here. So this is my first term. So this is going to be 0. So that's going to be 1. So my first term is 4. What's the next thing I need to know? I need to know r. What did I multiply by? Now here's the biggest hint I can give you. You could write this out, but if it's in sigma notation, whatever has the exponent on it, that's going to be r. R is going to be 3. Convince yourself. That's going to be 4 times 3. That's going to be 4 times 3 times 3. You're multiplying by 3 every time. And then you need to know n. Well, if you start at 1 and go to 6, n is 6. So our sum is the first term times 1 minus r to the nth power over 1 minus r. And this time you can just punch it in and get a decimal approximation. That's fine. So I did a little bit of cleaning up before I'm punching it into my calculator. And I get 1,456. So a geometric series, if r is bigger than 1, gets really big really fast, and if r is smaller than 1, it gets really small really fast. Let's do that finding the sum one more time. So I need the first term, which they give me. I need to know r. What did I multiply by every time? Looks like 1/2. Coincidental that the a and the r is the same. But I need to know n. How many terms do I have? What is n for 256? Well, we could go back to this formula and solve for n. So I have 1 over 256 equals the first term times r to the n minus 1. And again, you cannot multiply those together, order of operations. So I need to solve for n. So I'm going to multiply by 2 over 1. Reduce. I'm going to get 1 over 128 equals 1/2 to the n minus 1 power. So at this point you can kind of play with your calculator and see what powers of this is, or you can go back to something we learned. How do you solve for an exponent? You can take the log or the natural log of both sides. So the natural log of 1 over 128. Why would I do that? Because this can now come down in front. I can divide both sides by the natural log of 1/2. And get my calculator out. So I have the natural log of 1 divided by 128 divided by the natural log of 1 divided by 2. Be careful of all those parentheses, and I get 7. So 7 equals n minus 1. So that tells me n is 8. Could you have figured that out another way? Probably so. Just trying to review some skills that you may need for future math courses. So now I need to know the sum. So the sum is A1 times 1 minus r to the nth power divided by 1 minus r. Again, I did just a little bit of algebra first. Not algebra, but just a little bit of arithmetic. You could just punch it all in the calculator. Just depends how comfortable you are. And I got 0.9960935. I could have said math and said fraction and gotten that answer, and I like that a lot better. Look how close that is to 1. Why is that? That's because this raised to such a high power is so incredibly small, it doesn't take away much from our 1. That leads us to the next discussion, the sum of an infinite series, meaning can I add up an infinite amount of numbers? That sounds kind of weird. That's a calculus concept, finding the limit. But this is only possible if the absolute value of r is less than 1, as in the numbers are getting smaller and smaller and smaller. In fact, so small we say they become negligible. It is not possible if we're getting bigger numbers. We're multiplying by numbers bigger than 1. So we say the series converges if the absolute value of r is less than 1, and the series diverges if the absolute value of r is greater than or equal to 1. Again, some calculus concepts, but at a pre-cal level. So I'm going to ask you, does this series converge or diverge? Is it getting smaller or is it getting bigger? The numbers are definitely getting smaller, so we say it converges. This one definitely getting bigger, so it diverges. So this one, since it converges, it's getting smaller, I can find the sum by using this formula right here. The sum of an infinite series is the first term divided by 1 minus r. What am I multiplying by every term? Remember r, you take two terms and divide them, that's 1/3. So even if you took this out to infinity, which you really can't, but think about it, those numbers would get so small, if you added them all up, you would get 27. This one, the sum is not possible because you're adding larger and larger and larger numbers. Can't get there. I would like to take a minute and compare this formula to our infinite formula. The only part that's missing is this, and that is because of what we discussed in the last example. This number gets so incredibly small, we say it goes to 0, and 1 minus 0 is just 1, so I've just multiplied by 1. This only happens if r, being raised to a very large number, gets really small, like if I just keep multiplying 2/9 times 1/3 and then times 1/3, gets closer and closer to the value of 0. So here's our formula. Again, it can only happen if r, the absolute value of r, is less than 1. So can we find the sum on number 3 and 4? Well, this is geometric, and when it's written in sigma notation, that value raised to the power, that's going to be r. Is that less than 1? Yes. So can we find the sum? Yes. So the sum is the first term divided by 1 minus r. So how do we find that first term? We plug in that first value down there. So 2 times 3/4 to the first power, 2 times 3/4, that's 3/2. So we have 3/2 over 1 minus r. So the sum is 6. What about number 4? Well, what's r? Again, that, whatever's raised to the power, that's r. Is that less than 1? No. So this is not possible. And that's what you would say, or you could say it diverges. So we can only find the sum of an infinite series. It's only possible if that absolute value of r is less than 1. Not possible if it's greater than or equal to 1. And so you just need to know some of the formulas that we've gone through. So we have our nth formula for a geometric sequence. We have our sum for the geometric series that's not infinite. And then we have the sum of an infinite series. But that's only if the absolute value of r is less than 1, because r can be negative, and that's why the absolute value sign.